So maybe to get things started again, if you could all just join me in doing a round of applause for Debra Facktor as she comes out to moderate our panel.
Thanks, Brad. All right. Well, we will go as people are gathering, really excited to have our last panel of the day before Chirac speaks and focus on the national security sector. So we've covered commercial and civil. We got a little introduction from General Shaw and his work. And of course, I'm really glad we were not the ones exactly to follow Dr. Zurbuchen. How amazing was that to just see into the universe? So another important part of our space community is how we're applying innovation in national security areas, and really pleased to have representatives of 3 of the most innovative organizations that we have. So starting with Derek Turnier, who is the director of the Space Development Agency. He's a Purdue grad, so we allow him in with the Big Ten. I noticed that a lot of people were noticing how many Michigan people were on the organization, so it's okay. It's okay. We'll let you in. We'll let you in. And he has experience both in government and in industry. Prior to heading up SDA, he was at Harris, L3 Harris Corporation, and previously was at IARPA doing a lot of innovation on the Intel side. So he's got a tremendous story to share about what SDA is doing to really disrupt how the government is using low Earth orbit telecommunications and observation satellites for their own purposes. Brigadier General, I'll go to the end. Stephen Butow is the director of the space portfolio at the Defense Innovation Unit. So they are a really specialized organization that looks at partnerships across all different parts of space. Has an illustrious career in the Air Force and as a pilot as well, a lot of work in the National Guard. So I think you'll appreciate the perspectives that he is bringing as well. And then we have Colonel Stephen Landry from the Space Force in an organization that's been stood up for technology and innovation, and he's the director of digital transformation, which is a huge important area right now on looking at mission systems engineering and how we're applying some of our systems really to evolve depending on the threats. So we've got some great experiences and perspectives to share today. So what I first want to do, because we have a lot of young professionals in the audience and our Brooke Owens and Zed Facktor fellows, people who are new to the industry, is start with context setting and also explain acronyms, because there's a lot of them. We assume here that the audience needs to have that full understanding. So I'm just going to ask a basic question of each of you first is, tell us what you do. Like, what's your job? What does your organization do? And how does it fit into the national security ecosystem? And Derek, we'll start with you.
Thanks, Deb. Yes, while at the Space Development Agency, we don't look into the universe. We do, protect America and our allies, just to protect and keep safe the free world. But that's important too, Deb. Just so we're all clear on that.
Absolutely.
No, actually, I was really excited to see James Webb up. The company L3 Harris. My business unit at the time was building the telescope for that. So really excited to see that gone. And to put that in perspective, when did that contract start? You were at Ball.
I was at Ball. Actually, I was at Ball Aerospace previously, and we did the mirror. So that was actually the jewelry that some of you got. That was all built by my alma mater. And that was already underway when I was there, and I was there 7 years, and that was 9 years ago.
So we're going to come back to that because that's important, because that's the whole model. So what we do at Space Development Agency, we are tasked with completely changing the way the Department of Defense does national security space. So historically, national security space was always done by taking exquisite capabilities, putting them on very expensive satellites, similar to the James Webb, and doing that over a course of maybe takes 10 years to build a satellite. We're just talking about James Webb, at least 17 years longer in the making, and then put that up there and it would last for 20 years. And that was, at the time, the most efficient way to do it, especially when space was a relatively benign environment. Nowadays, that's not the case, right? Space is challenged. So in addition to that, commercial entities have come up and made it extremely more affordable to fly things in space and commoditize components for making smaller, more affordable spacecraft. So if any of you have read Clayton Christensen's book, The Innovator's Dilemma, and if you haven't, I strongly recommend it. In that book, he basically says, if you want to create disruption, you need to do it from outside of an organization. If you're within, you're always going to go with established customers. You're going to develop resource processes and values that give the customer exactly what they want, right? Henry Ford always used to say, if I asked my customers what they wanted, they would have wanted a faster horse. So Space Development Agency was created outside of what was historically national security space to completely disrupt that model, the model of high exquisite satellites that would last for tens of years, and focus on two pillars. Pillar number one, proliferation. Following what commercial industry has done, we said, hey, look, we want to be able to break those constellations up into hundreds and hundreds of satellites, be able to fly them. And pillar number two is spiral development. What that means is no longer 10, 15-year development cycles. We want to fly new satellites, new complete capabilities every 2 years. Let them last for 5 years, and then you basically get new capabilities and do that. And so based on that model, we've created an entire architecture based on those two pillars, proliferation and spiral development. And that's what we're all about. We're all about putting satellites up there by the hundreds that allow us to have low latency communication, that allow warfighters to communicate directly with people that are calculating a fire control or targeting solution anywhere in the globe, and have those data go directly down to a weapon system that could be anywhere else in the globe. That's number one. And then number two, do the same thing, except now I want to be able to detect and track new missiles, hypersonic glide vehicles, heard a lot about those in the news, and those kind of activities, and track those and send those data down directly to an interceptor, and do all of that from these hundreds of satellites. And you're not going to get it right out the gate, but you know what? It doesn't matter, because every 2 years you're going to put these new constellations up, and you're going to continue to further that capability based on what is state of the art. So that's what we're doing at the Space Development Agency. We're actually 11 weeks away from our Tranche 0. We call our spirals tranches, just because that's got to be cool. So we use that term, tranche. So we have Tranche 0. That launches in 11 weeks, and then 2 years later we'll launch Tranche 1, and we'll just continue that spiral development approach. That's what we're doing.
Very good, thank you. Colonel Landry, maybe you can tell us a little bit about what Space Force is doing. You have a vision for a digital service and what that means with digital engineering, digital workforce, digital headquarters, digital operations, digital everything. Tell us a little bit about that.
Yeah, Debra. So thank you very much. So first off, on behalf of Dr. Lisa Costa, who's my boss, she's the Chief Technology and Innovation Officer for the U.S. Space Force in the Office of the Pentagon, working directly for General Raymond. I'm glad General Shaw kind of gave you a Space Force 101 on how it's kind of organized, where the services are responsible for man training, equipping, and the combatant commands are actually the ones that prosecute the fight if and when needed. So on the space staff, the CTIO office is not responsible for doing all of the innovation or the technology within the U.S. Space Force. Innovation can come from anywhere. But what we were really trying to do is to understand what the pain points are out there within the deltas. Deltas are one of our levels of command. So just like the Air Force has wings, we call them deltas. We have squadrons below that. So it's a different echelons of command. Air Force, you have major commands. We have field commands. So at the delta level and below, which is the individuals that are really out there where the rubber meets the road and are really trying to get the work done above at the tactical level. We're really trying to identify the pain points that exist for them. But pain points are spread throughout the entire force. We are a very small force, supposed to be, roughly 18,000 strong in the end, is what the end strength for the Space Force is compared to the other services. And only about 8,000 of that is roughly 8,500 is military. Don't quote me on those numbers. but we have a lot of pain points. So we're really trying to figure out how to do more with less, but do things smarter than the way things were done in the Air Force, because we picked up a lot of our mission from the Air Force. My background is I did 29 years in the Air Force, and just last June of last year is when I was cross-commissioned into the Space Force. So we're bringing in people from the different services, and they're all cross-commissioning. We've had the first couple of people actually come into the Space Force as, actual guardians and never being in any other service. But they have very innovative ideas because they're at that grassroots level. What we're trying to do at the CTIO is understand what people are doing here, because if they're doing something on the East Coast, they may have the same problem on the West Coast, and we want to make sure that we're not wasting money and time or effort when we can either combine resources, or if the problem has been solved over here, we can utilize it over there. One of the things that General Raymond did in conjunction with our office was develop a vision for digital service that Debra mentioned. And it breaks everything down into 4 focus areas, is what we call them. I know one of the questions, we'll get into it a little bit later, but I see it as digital engineering is kind of that base level. You have to have everything outlined, and everything needs to function well together for a digital engineering environment, digital engineering ecosystem. Above that, with the digital workforce, you have to have a workforce that is digitally fluent. We have training courses that every guardian, military and civilian, is required to take in order to make sure that we have, if we're going into a meeting and we're talking about MI or machine learning or artificial intelligence or whatever, we have that baseline knowledge across there. So we have to set that baseline to make sure everyone has a common understanding. Because one thing that General Raymond has said is he wants the Space Force to be the first truly digital service. We are being born in a digital environment. Unlike the other services that grew up in an industrial age and have a lot of those industrial age bureaucratic baggage along with them, we're trying to reinvent the Space Force to be purely digital and leverage that as much as we can. Above that, we have digital headquarters. So digital headquarters is really taking a look at all of those bureaucratic, industrial age policies and procedures that people are doing, and trying to automate the ones that can be automated, streamline the ones, making sure that we can make decisions quicker, better, faster than we have been when the space missions were in the different services, leverage the technology that has been increased over time, gaming technologies, the metaverse, you name it. We'll get into some of those conversations a little bit later. But all of that has to build to a point. And if we are not focusing the engineering sections and the workforce section, the people, and the policies to support operations, so General Shaw and U.S. Space Command can prosecute the missions that they need to, then we're not doing our job. So that's how we build it from an innovation standpoint within the Space Force, is using that vision from General Raymond to create that initial digital service. I will tell you, my background is not space. I was one of the people over there when General Shaw asked about, space's BFF, which is cyber. That's what I am. Degrees in computer science, emphasis in computer security. Previous 11 years were up at NSA doing offensive and defensive cyberspace operations. So that's where my focus is being able to leverage that computer and information technology to enhance how we do things within space and do it in a new and innovative way, leveraging non-standard technologies like gaming systems in the military to be able to do things quicker, better, faster than our adversaries.
Thank you. So, Bucky, DIU, innovation, is literally your middle name of Defense Innovation Unit. So tell us, what does that mean? What do you do?
Sure. Well, first of all, it's really a pleasure to be working cleanup on this lineup with Space Development Agency, who's our favorite acquisition entity, and they're also a partner still in research and engineering, and the Space Force, which to me actually is the one component that makes my job easy. So what do we do at Defense Innovation Unit? We're there to accelerate the adoption of commercial technology in order to transform our military capabilities, and most importantly, to build and grow the industrial base that supports all the things that we need, not just for our military instrument and national power, how we defend the nation, but also for a stronger economy, for better jobs for folks like you who want to contribute in some way to not just making sure we can defeat missiles, but we can go explore the moon, Mars, and have other ambitious things. So it's really fun. Why do we do this? Well, it turns out that back when I was in college, the government was just a juggernaut for research and development. During the Apollo era, it turned out that the United States accounted for maybe 2/3 of all the research and development expenditures and globally. And defense was a huge driver of that. Over the decades, as we've kind of transformed our economy and more adoption, the commercial sector has taken on a larger role in terms of the expenditure of research and development dollars, to where the commercial sector today outspends our government on an order of like 3 to 1. But more importantly, if you look at technologies like artificial intelligence, cybersecurity, space, many other things, autonomy, there's a very strong nucleus of talent and energy and private investment that are going to advance these technologies much faster than what we could do in the government space alone. So why not leverage that? And so that's really our role. Derek does acquisition. I do discovery. So he designs, builds, and has programs to build and implement things. And if I'm doing my job, what I do is I build a menu of mature, validated commercial solutions that he can pick from and use in his spiral development at a later time. That's why I love him so much, right? Because most of the government doesn't do procurement that way. They do what's called waterfall engineering. They'll sit down today, they'll design something that they're going to build, and I'm in the Air Force, and our track record's typically about 16 to 19 years right now, which is really sad. But and in order to make sure that the equipment works, they backdate the technology maybe a decade so that we have the most reliable equipment. Well, that works for reliability, but it doesn't work so well for cyber, does it? So what we want to do is we want to really transform how we adopt and use technology. It doesn't always have to be commercial, but we should be commercial forward where we can be, and then increase the pace of agility so that we stay tightly coupled to today's technology and solve problems and build a stronger industrial base and create more opportunities for people like the folks in this room to participate, which is really kind of cool. So I hope I answered your question.
Oh, no, that was good. And actually, can you give us an example of one of these tough problems that you're trying to solve, and how, I mean, you brought up so many different things, pulling in commercial or civil and cyber and artificial intelligence. Like, give an example that might give a context of what you guys do and how that might feed into one of the mission areas.
Sure. Well, I'll use one of the early projects we used, which was about 5 years ago. Derek was actually in some of these meetings, but we were asked to go out and work with the commercial sector to find a commercial source for synthetic aperture radar imagery from space, right? Those small sats. Why is this important? Well, we like to be really good allies, work with partners and others, and solve problems where we need unclassified sources of imagery. And synthetic aperture radar would be something that, back in those days, you would either get from a national security organization, or you would buy from companies in Italy, Germany, Canada, or Japan. And so we didn't really have any US sources. But more importantly, at that time, we were in a transitionary period where we want imagery that's optimized for computer vision, advanced algorithms that you can run in the cloud. So with the vision being that, hey, we like human analysts, but by, really at the turn of this last decade, there's more imagery than there's humanly possible to process on any given day. So how do you take advantage of technology to solve that problem? So we did that. We've worked with a couple of companies in the commercial sector, and many of them are doing very well, and they've transitioned and are working with other people in the department on contracts, and that's good, as a service, right? So that means we don't design, we don't build, we don't sustain, we just go and we buy data as a services through our transition partner. On this side is the National Geospatial Intelligence Agency working with the National Reconnaissance Office, and they do the procurement, so they're the acquirer for that solution. And what we do is we do the kind of the hand-holding and coaching, helping these commercial companies to make their products and services available in the commercial marketplace. So that's an example.
Mm-hmm.
We have others, but I want to try to keep the space theme today.
Yeah, very good. Derek, you want to add on to that, or some of the innovations that you are both, there's always a push and pull in innovation. Are you pushing something in, or are you pulling it from the commercial sector, another part of government? So can you give us an example of, I don't know, your toughest problem that innovation is going to solve, and maybe a handoff from one of Bucky's
Sure.
ideas.
So it's actually, there's a lot of handoffs there, and it's funny because I always say that Space Development Agency is an incredible misnomer because we don't really do any development. When you think about development, you think of technology development. A lot of the things that Bucky's, they invest in these startup companies that are doing a lot of real tech development. And we don't really do that. So when we say the development means architecture development and fielding this whole constellation of satellites and how they work together in unison. And so if you talk about how I view innovation from that lens, not from a lens that is really looking at taking the latest technology and trying to push the limits on that and get the best technical solution. But the innovation I'm looking at is how can we take what is available now that someone else has developed, whether that be DARPA, DIU, one of the research labs, anybody else, commercial industry, whether they have already developed that, how can I get that turned into a military capability as rapidly as possible? And that's what we're focused on. And so some of the examples, and this permeates all through, right? Our motto is Semper Citius, which means always faster. And our unofficial motto is better is the enemy of good enough. We want to take solutions and we want to field those because you know what? We've got another one coming up in 2 years. So what are some good examples of that? If you look at what this is predicated on, this whole constellation of hundreds and hundreds of satellites, it's predicated on solutions that have already been commoditized by industry who have developed these technical solutions because they thought there was a business case for them. For either satellite internet from low Earth orbit, where they hundreds and thousands of satellites to be able to do that. Several companies doing that. And then so what we've done is we said, we don't want you to change completely what you're doing. We want to take, for example, we want to take a OneWeb satellite, have it modified slightly so that it can fly a military payload, and then get that up to orbit as rapidly as possible. And oh, by the way, we want to do that. We want to buy 100 of them and do that. So that's when I look at innovation, I'm looking at innovation of a completely new way of thinking about how to solve a problem, not how to solve it from the most technically exquisite way, not starting with a blank sheet of paper, but essentially starting with something that you have these pieces and parts. What is the fastest way that you can kludge those together to get an architecture, to get the capability, and then just expand upon that every 2 years?
Thank you. And actually, I appreciate the shout out there, and really from an industry standpoint of the opportunity to bring investments that we all make. There was a lot of talk this morning in the commercial, and it came up in the civil panel as well, where industry makes investments and the government is a super important customer, and being able to do both, bring that agility and everybody take advantage of dollars spent and technology demonstration, so that by the time it comes to you with what you're doing, which is different, it's proven, you know what you're buying, and you can do it fast. It really is transforming how government is doing business. Totally in contrast to preparing something like James Webb Space Telescope, which is not a fast mission, and it's not supposed to be fast either. It had to be as precise as it is. So speaking of the, this kind of going quickly and how that contributes to innovation, Steve, maybe you can talk a little bit about, Space Force is getting stood up, like everything's new. So when you're innovating literally from the ground up, how are you doing carrying out your mission and building your whole capability at the same time, and doing it all digitally, which sounds to me like it's a paperless organization. I don't know if that's what you really mean, but when you talk about some of these things being all digital, what does that really mean? And how are you doing that?
So I'd say, taking a step back and looking at the Space Force. When the Space Force was stood up and it was signed into law in December, it existed that day. General Raymond became the first member of the U.S. Space Force that day. But we already had missions. As missions transferred from the Air Force and, now coming in from some of the other services as well, we couldn't really stand up we didn't have the opportunity to stand up the service, and then create our mission, sorry. I thought I hit the button, sorry. So really looking at it is, we were standing up the service, but we still had to continue to do the existing missions at the same time. So we couldn't stop doing what the support we were providing to U.S. Space Command, who also was standing up at the same time, but also the other services. Running the GPS constellation, which is one of the Space Force's mission. Someone mentioned earlier about, they found this building by using the app on their phone. We couldn't just stop running the GPS constellation. We still had mission going on. What we're really trying to do is take a look at the existing processes and procedures that we inherited, not only from the Air Force, but from the other services, and figure out how to do those better, faster, and smarter. And if we can get away from doing it on paper and do it all digital, great. But one of the problems that we're running into is, as the smallest service, we have the advantage of being able to fail fast on a lot of things when it comes to a lot of those processes, because we're so small that we don't impact the entire department of the Air Force. One thing that wasn't mentioned earlier was, just like the Marine Corps is part of the Department of the Navy, the Space Force is part of the Department of the Air Force. So we still have to live and breathe within the Department of the Air Force, and there's still a lot of those industrial age bureaucracies that the Air Force has been utilizing for decades, that we're having to try and figure out better, smarter ways to do that, like I said, but also nudge the Air Force in that same direction with us. And I think one of our biggest challenges is not the technology, but it's actually the cultural. Being able to change the digital culture of an industrial age bureaucratic organization is one of the biggest issues that we've run into. And some of you all may not have run into this in your lives yet, but you will when you go to change something and someone says, well, that's the way we've always done it. Because that's what they're comfortable with, that's what they are used to doing, and they can go in, they can do it with their eye closed, and they can go home. They don't want to have to think about it because they've been doing it for a while. So that's one of the biggest things that we're really trying to do, is leverage the size of the Space Force to, I wouldn't say manipulate, but be an experimental area for not only the Department of the Air Force and the Air Force itself, but for the DoD, to try and show people that there are better ways, more innovative ways to leverage existing technologies and non-standard technologies, looking at technologies that may be in areas that you may not even think about it. And I don't have a good example right off the top of my head, but looking at One of the things the CSO is getting ready to take a trip out, and one of the organizations he's going to be visiting is John Deere. Why? Well, it's because in the innovative cycle, they have really figured out how to reinvent themselves. And in looking at some of those organizations that don't do the exact same thing that you do, can kind of, turn that light bulb on and make you realize that there are other ways of doing things. Because not every organization and not every person has a monopoly on good ideas. So you have to figure out how to leverage them across the government and across the industrial sector, and not just in the defense sector as well.
So I know I want to make sure we have some time for questions out there. Let me take a little pause if we have a question. Sophia?
Nice. That's good. Well, I'll start off. So again, my focus is with the commercial sector. One of the most important things we can do as a government is be a really good customer, right, of things that come from our industrial base, and then send a strong signal, as Derek in the Space Development Agency is doing, that this is not, we're not going to buy something and wait 20 years. We're actually going to have a continuous process of spiral development or spiral acquisition to bring new capabilities on board. So what you do is you send a strong demand signal to industry. How does industry respond? Industry responds by building more talent and buying more parts and positioning themselves for the long run. You, right now, everyone in this room that's basically in your probably early 20s, getting ready to finish college, this is probably one of the most exciting times, actually in human history, if you think about all the profound things that are going to happen within your lifetime. I mean, it's quite possible that within your lifetimes, we're going to have human settlements on other surfaces like the moon or potentially Mars, and actually having our economic system expand further out beyond low Earth orbit. So, and that's just in the space realm, right? There's so many great opportunities. The interesting thing, 2 years ago in 2020, during COVID, there was a record was broken for the amount of private investment that it went into the space sector, and it was about $7.5 billion. Last year, $15 billion was invested in the same sector, which is another record. And we're not alone. Our friends and even some of our non-friends are making equal investments in these technologies. So if we're going to be competitive, if we want to retain our stature as a industry leader, but also a leader for democracy, liberty, and prosperity in the world, it's really important that what we do is develop talent and you're our future. We're vested in all of you, and that what we do is we make sure you're an engineer. And what level of degree are you getting right now? Bachelor's, master's, bachelor's. Okay, keep going. Don't stop. Don't stop learning. Because here's the thing: we're actually worried that we're going to have a talent deficit in a lot of these key areas. So if you're in engineering or science, please stay there. Please resist the temptation to get a job on Wall Street. Go work and do the things that you learned to do at school. Encourage your friends to do the same thing. Be bold. Some of you are in uniform. Do a stint of work on the government side, maybe with the Space Force or maybe with Space Development Agency, and participate. Because again, this is a very exciting time. There's so many opportunities abound, and you be very demanding of us, the senior people in the room, that we position you well for the future. And that includes not just talent, but diversity. We need more diversity in our ranks so we can problem solve and do an extraordinary job of keeping things safe in the future.
So Colonel Landry, maybe on that, thinking of diversity of thought, you mentioned you're not a space guy, although I think now you really are a space guy. Maybe answer the question about growing a workforce when you bring in people from different domains into space.
So I'd say that it's a very interesting question. You know, one of the things when the Space Force stood up, they looked at all of the different career fields within the Air Force and figured out which ones they wanted to bring in. And they decided to basically bring in, and this is, I'm going to talk the officer career fields, but they have the requisite enlisted career fields that go along with them. You know, so the obvious one is the people that were doing space operations type of activities in the Air Force. You know, that was given. That one's coming over. One of the other ones they looked at was, you know, along with looking at what SDA does is our acquisition career field. So they brought over some of those individuals and some of the engineering aspects, developmental engineers and stuff to go along with that as well. So those were kind of the given ones that they really wanted to. But there's two other aspects, and General Shaw really touched on one, and that one was cyber. You know, you can't do anything in space these days without cyber. Whether it's electronic frequency or it's actually, you know, cyber enabled space operations or space enabled cyber operations. You know, everything works through a network of some aspect, whether you can affect it via a cyber attack or whether you can do it via electronic warfare. So that was one of the career fields they brought over, was the cyber operations with emphasis on cyber defense. And the other one is to enable all of that, you have to know what your adversaries are up to, and that is the intel. So those are the main career fields that the Space Force brought over from the other services, and the rest of the more administrative type of activities are still being provided by the Air Force to the Space Force. You know, so from that aspect, coming out of the Air Force, we really didn't have that much of, we've been working together for a long time. So a lot of that made sense. I would say one of the biggest challenges we've had really is just trying to figure out how to leverage those technologies that we were talking about earlier. So the challenge was not necessarily people working together from the different aspects of the force, because we've been doing it already. Our challenge now is to bring in our brothers and sisters from the other services into the way that the Space Force is doing business, because we're trying to do it different from all of the other services.
Thank you. Derek, I'm going to let you wrap it up with our last question of the day. Is we talked about a lot of different kinds of innovation, lots of different sectors. What advice would you give our young professionals in the audience today pursuing the career with so many choices ahead? What would you advise?
Take a lot of math classes. No, so you know that. Look, I agree with Bucky. This is really exciting time. So if you just to give an example of how the space career environment has changed. When I was in industry, we were delivering the payload for the GOES-R instrument, weather satellite, and people on that were going. Their kids were graduating high school at that time. And they were reminiscing to me, yeah, I remember when we won this contract, my child just started kindergarten. I said, think about that. 12 years, if I could see, more math. 12 years, 12-ish years on the same program. You know, that's why you sit and think, wow, that's good work if you can get it, I guess. But realistically, that's not the way space is going to go in the future. You know, now satellites, we're gonna launch satellites every 2 years. Commercial industry is going at this speed to where really the pace of innovation and development is much more rapid. That time, I think, is gone and past. And so how does that apply to you starting out and what you should prepare yourself for and what you should look for? So a couple things I would I would certainly encourage. I would get in that mindset that every job you take is going to be about learning so that you can expand and move forward. And so how do you hear that a lot. How do you actually apply that? Number one is I think you should always look at going above and beyond of doing things that are outside of your job scope to help you grow, because that's what's going to allow you to basically move from one capability to a complete another one. And people always say, change is good. Well, that's a saying that you hear. What does that actually mean? Well, that actually means that you've got to get in this mindset that you embrace, that you're going to work on something for a few years. Everything, it's just a learning experience. That job, that project you're working on is not a career. That's a learning experience that you can deliver a capability and move on to the next step and continue to grow, because then that experience base you will take with you as you move on. And that's where we'll really grow the strength of the industry, to try to get these people with all these different diversity of experience base, people working on different parts of spacecraft, people working on end user equipment, and bring that in. It's one of the things I pushed at the Space Development Agency from day one. We brought in a lot of folks from the military. We had military billets to pull in. And the Space Force and the Air Force wanted to give us people that had experience building satellites. I said, no, you don't understand. I said, I've been doing that my whole career. We have a lot of engineers that have been building satellites their whole career. I've forgotten more about building satellites than almost anyone that will actually be in uniform, because that's not what they do. I need people that can actually bring in a different viewpoint, that knows how are we going to use this capability to actually give the warfighter what they need. So that's a complete mindset, because typically in acquisition and engineering, people don't think about that. So that's what I say. You want to get this broad experience base and try to look out. And as you look for your first job, go to try to figure out look at the boss more importantly than the job, because that's going to set the culture, it's going to set the environment, it's going to set what you learn. So that's one thing I would look at, and then always try to figure out what's the boss need, and then deliver on that, and you'll do great for your career. But if anybody, we're always looking for engineers and folks at SDA, so you can always go to www.sda.mil and we have applications there. But no, that's what I would leave you with. It is definitely a hot time to be in space. I think it's going to be growing for several decades, and it's just a bright future.
Hey, can I reattack and just add one quick thing based on what Derek said?
Okay, keep it short.
I will.
Keep it short.
Innovation is a team sport. Join a good team. Don't be focused on the technology. Join a good team. Find a good mentor, and that's worth its weight. Everybody who's up here on the stage, not just this, but earlier today, they all had good mentors. But join a good team. We'd rather choose an outstanding team over what we think is an outstanding technology, because then good teams can always solve everything. So thank you very much.
Great advice, thank you. So lots of innovation, regardless of any part of the space sector. Please join me in thanking Bucky, Steve, and Derek for giving advice today. And I'll turn it back over to Brad. And if my team can join us over there.